So welcome everyone. Thank you for joining us in this Open Security Summit January edition session. We are joined by the co-founder and head of data science of Debrit. So let's welcome Emil. Over to you, Emil.
Thank you. It's great to be here. So today I'm going to talk a bit about open source and the rise and fall of open source projects. I've been looking at different research and data myself to understand different indicators of success or the failure of open source projects within the modern ecosystem. Um, um, but but first of all, my name is Emil Wåreus. This is my email. If you have any questions afterwards and so on, you're of course welcome to connect with me on LinkedIn or just send me an email, and I'll get in touch. I'm the co-founder of a startup in Sweden called Debrit. We do software composition analysis and everything in regards to open source data. So I spend most of my days looking at different data points within open source, building machine learning models on those to find security issues within open source projects, and looking at the quality metrics of open source projects. And as we all know, open source has completely exploded in the past couple of years. For the Python package managers, pip, there's been a 360% growth in the number of downloads for the past 2 years, which is a tremendous growth. Looking at it's not only that we're using more open source as well, we're also producing more open source projects. Looking at the same package manager for Python projects, we can see that there's about a 61% increase each year for the number of open source releases per year. So the number of unique versions released on the package manager. The 2021 staple here is actually made when 2021 was over, so it's probably a bit higher even today. And just to gain some perspective, Mark Andreessen said about 12 years ago that software is eating the world. Well, the growth of open source in Python, in the Python community, has grown 2,700% almost in that time. So software and open source is truly eating the world. And this is not the only hobby and student projects using open source software. It's of course large corporations and industry as well. Looking at industry code bases, the saturation of open source, so line by line, how much of the code base is open source, has gone up from about 35% to almost 80% to 2020. So the usage, the downloads, and how we write open source has vastly increased the past years. And looking at the impact in the industry, we are seeing that the leading companies are 75% more likely to use open source compared to the lower performing companies in terms of revenue and so on for tech companies, and those high performers are also more likely to attribute their success to somewhat to open source usage. And one thing that I don't have a number on here is that even when the leading high performing companies are using a lot of open source, they also have a higher extent to want to use even more open source than low performers. So there is so much to gain from the usage and participation of this vast community. But I'm going to make a statement, and this is that dead projects can or should maybe be considered tech debt, because most of, at least me, using a lot of open source and have used it a lot of different projects for a while, choosing the wrong project that dies out when when I'm still wanting to contribute features, or maybe there are bug fixes that I was hoping for would come up in the end that don't come up, that project quite fast becomes tech debt. And this has happened to us at the Brick as even to my former employer. So I think we should view dead open source project as something that, like, could we improve this process? Could we get better at contributing back, but also at choosing and knowing the indicators of why open source projects may rise and continue to thrive, or may fall into an unmaintained state. And I have an example here where I was building I develop a lot of my code in Python as a data scientist, but I was building this API and wanted to document it with some beautiful Swagger and Open API documentation. And there was this great framework out there which I really liked. It was quite early on in its development. It was called REST Plus. It automatically made some input validation, some marshalling, and generated beautiful documentation to my API. But sadly enough, after we used it for a while, the maintainer suddenly stopped. We had merge requests to that project that we wanted to get in terms of using multiple different documentation sites for different parts of the API and so on. And as we can see here, looking at the commit history, it suddenly died out. I don't know exactly why the maintainer stopped, but he was completely unresponsive, and maybe it was the case of maintainer burnout for this project. But luckily, a community fork appeared. So the community liked this project so much that they forked the project and it became RESTX instead. It was the same code base, but they just started maintaining the fork. So we swapped it out just when we started and kicking, and it's been a great experience to contribute to RESTX even to date. But there are some challenges when projects die out like this. I think one of the most pressing one that we have seen today, especially with Log4j and so on, where vulnerable code can live undiscovered for a very, very long time. So you need a continuous project to manage the security of the code in that project. It needs to be active. So I extracted some data on vulnerability time to discovery. And on median, it takes about 800 days to discover that a piece of code in an open source software is vulnerable and disclose an official vulnerability on that project. So the code is insecure and undetected for about 800 days in median. This, of course, varies a bit depending on language. Python was actually quite good. It had a bit lower median. Ruby was not so great, and Maven was not so great either, or Java. So we need continuous management of these projects and monitoring for not only feature and bug reasons, but also security reasons. And how did you pick your open source project the last time? What did you look at? Well, what kind of parameters or features of that project did you inspect before making a commitment to, like, okay, this does not only solve my problem, it's a good community to use continuously? We have done some user research, not any official papers on this or so yet, but mapping out the process of not what developers or security experts want to do, but what developers actually do within the companies. And there are some key features here, the key parts here that I think is important. One, functionality trumps most things. Like you want to solve problems with open source, so find open source that solves your problem, of course. But they also look at requirements such as security and licensing and compatibility to your current stack of these projects. And in the evaluation step, when you have candidates to evaluate in regards to if you can use it and what suits you best and so on, there's actually a lot of community aspects that you look at, like the activity in the project, the reputation, the complexity, the longevity of the project. We got this one a lot, and the popularity. And there's usually a team discussion around this as well. So I spend a lot of my time looking at this community data and trying to figure out what indicates long popularity and long-term thriving of a project. But let's first understand why projects actually fail. When does this happen, and why do maintainers choose to not support the project anymore? And looking at this research paper, I found that looks into why modern open source projects fails. It basically divides it into 3 different reasons. It's due to the project, due to the team, or due to the environment, where the actual project was the most common reason, where we're looking at that the project may become obsolete. If you're building something that is a patch to, let's say, that is a minor utility for React, and React includes that utility in a future release, then that project becomes obsolete. And that's a common reason to why maintainers choose to stop their projects. And there's also, but the most common individual one was actually that competitors usurp the project. And in most cases, it was that large companies such as Google and Facebook open sourced their internally used solutions, such as React or Metaflow and so on, to build a community around that, which is great. But then other communities may become usurped by these projects, and that becomes a challenge as well. So, but there's also some aspects within the team where you have lack of time and lack of interest in the project as well. Maybe this is something in relation to maintainer burnout that is a common term these days. But I think there are 2 main things to take away here. That the other projects may come in and that functionality may exist elsewhere, where it is a more modern and more recent solution, and then there's an opportunity to follow the trend. But then there's the challenge of that there may not be a good alternative, but it may not still be maintained anyway because of lack of time and lack of interest from maintainers, and this can somewhat be prevented by good research into the projects that you may want to include in your software. And looking at like which projects fails, and now we know a bit more about why they fail, why maintainers choose to stop. But I think it's interesting to try to predict which projects may fail and what is associated with what risk is associated with different projects. And looking from the same paper, I found that there's a distinction between projects that fail and projects that are successful. And there are some interesting factors here that I think we should consider. Here we have a column where how common was these practices within the failed projects, and then we compare those to some of the top projects, and then we compare those to some of the bottom projects, and then we have a random sample. And here we can see that top projects have really good usage of continuous integration and a contributing.md, a guideline for new contributors where they should look and how they should go about to contribute to that particular project. And failed projects had to a lesser extent, both continuous integration with testing and automatic deployment, and also this contributor guideline on how you should go about to contribute to this project. And when you think about this kind of makes sense, of course, that yeah, if you don't write out like this is how you can support this project, then less people will support this project and it might die out and stop being contributed to. But I think it's interesting that the data actually supports this so well. And there's also some correlation here with templating and making it easy to submit issues and adhere to a code of conduct, but to a lesser extent. The READMEs had no particular correlation, and but we can see that both licensing of the project, like clear licensing with a license file that is XPDX compatible, had some indication, but also that you had a dedicated homepage to the project had indication on whether it would fail or not. There is also another aspect of this, of looking at how many really active core team contributors you have in a project. Those are called truck factor developers. So usually a truck factor developer is, if you count all the maintainers and contributors to a project, how many of these core team developers would have to stop contributing for the project to die? That is the basic question and identification of truck factor developers. There are some different methods to identify how many truck factor developers a particular project has at any point of time. Usually it involves looking at how many commits you've made and to what files and how much of each file each project member has written and so on. It's a bit involved, but a truck factor developer, you can view it simply as one of the core team contributors of that project. And there's actually a very strong correlation with the amount of truck factor developers you have active in a project, the amount of core team contributors, and the risk of the project going unmaintained for one consecutive year. This is what this paper called the truck factor developer detachment. This is the event where during one consecutive year, none of the core team contributors contributed code to the project. And for a sample of about 2,000 repositories, 16 of these repositories had these TFDD events. But it's not to say that that means that the project is completely dead for eternity. 41% actually survived and got new core team developers to contribute to the project, and the project lived on. But looking at the amount of these core team developers, there is actually a high correlation with fewer core team developers, and that the project went unmaintained for one consecutive year. For the subset of these 16% of that had the TFDD event, when this event happened, they only had one truck factor developer for 2/3 of the cases. And 1/4 of the cases they had 2 developers, and for 7% they had 3 developers, and so on. And so looking at if the project you're considering, if they have an active core team that of a diverse core team of developers that's actively contributing to the project, is an important factor here to see that it will live on even after the current day. So we have looked a bit on what projects actually may fail and why the maintainers choose to quit the maintenance of these projects. But I think it's really interesting as well to look at like what projects actually take off and how. And I found this really interesting data on how projects grow. So looking at the growth speed of different projects, these are the top, this is the amount of stars on the 5,000 most popular GitHub projects from a few years back though. They were able to cluster the growth of these projects into 4 different categories. So 65% of these projects were slow growers. And by slow, it's actually not that slow. If you compare this to normal investments and like stock markets and so on, 27% growth per year for the slow growers, I think that's quite tremendous in terms of what growth actually is. But the vast majority of the popular projects are growing quite slow today. But then there's the moderate growers where you have over 90% growth per year, about a fourth of the total sample group. And then there's the fast and viral growers, where we have about a 6% subset of the group were fast on 460-70% growth per year, which is huge. And the viral growth, where the projects simply take off with a 2,600% growth per year. But those projects are very few, only about 1 to 2%. But what indicates growth, actually, I think is quite an interesting question to ask here. And looking at different aspects of this data, what projects, what different subsets of this data had more fast and less less slow growth, etc., is quite an interesting thing to look at here. So if we start off looking at the language distribution, we can see here that we have a couple of different programming languages and slow and to viral growth here. We can see that Ruby is quite a snoozer in this particular data set, but Java has really high growth alongside with Go here, which I thought that was quite interesting, that Java had such high growth for being one of the more mature programming languages. But looking into the subset, about this article was from 2016, and during 2016 there was a lot of development for mobile, and it was a lot of development for Android, which is written in where you can write projects in Java. So a lot of Android projects, I think it was 2/3 of that Java fast-growing subset were Android applications. And Go, being quite recently released, one of the newer languages that had quite a lot of high growth as well during that period of time. But looking at the viral growth, which I think is quite interesting, Python had the highest share of viral growth here. So there was about 5% of Python packages in this set were virally grown. But looking at the share, not the share, but the total number, it was JavaScript projects that had a total of 10 projects in this set that grew virally. If we look at the next section, which is the domain of each project, we can gain some quite interesting insight that documentation actually is the highest and fastest grower, and web applications are a bit of are on the slower part of this scale, and that's quite interesting in many ways. And what the paper found was that the growth comes, of course, from solving a real problem and so on, and looking at something that people actually want, but it also comes from the absence of competition. And there's a lot of competition within web development in open source, and especially within large company-backed open source projects such as React and Angular, and building web open source for the web. Where there's a lot of competition, there's not much room for there's not much room to outgrow these large players that are already there. While on documentation, sadly enough, maybe not enough developers do really good, great documentation. So when someone actually does that, it has a higher chance of growing fast. Something that I found some comfort in actually is that it doesn't really matter if an organization releases the open source project or if it's a private user, which is quite great. So looking at the distribution between organization and the user, there's basically no difference in the growth speed. So, and other activity also correlates with this growth in the project. I think is interesting is that the total number of stars do not correlate at all with age of the project. So looking at these very popular projects and its age, it doesn't matter. It's simply it's more about you're solving a problem than how long the project has existed, which is quite interesting. And for newer projects starting out, I think this can be encouraging. But the activity in the project and how much it has been developed definitely correlates. So looking at the number of commits has some correlation with the amount of stars, and more so the number of contributors. Of course, furthest to the left, to the right, we can see the amount of forks correlate quite heavily with the amount of stars. But then you can also ask the question, why do you fork a project? There are lots of reasons to fork a project, not only to contribute back. So, can we predict where an open source project will rise or fail? There are indicators, and I think that's there are some quite interesting indicators on this, and looking at whether it's easy to contribute to the project and it has a correct and good setup according to the GitHub standards of making a repository and building a community around that, actually has positive correlation with the survival and the popularity of the project. So there are some prediction powers in these parameters that you can look at when choosing different open source projects. So somewhat, yes, you can at least view it as being risk averse and acquiring the right knowledge of the projects that you're trying to pick and choose from, whether it will be a long-term commitment or if it will, or if it may become you risk it, that it will become a fork of death. But in the end, I mean, as I think looking at the risk around open source can quite fast take a bit of too much of a negative tune, I think. Tying back to the start of my presentation, where we're looking at how the open source communities and usage and contributions has completely exploded for the past both 10 to 5 to 2 years. It's not this is icing on the cake in terms of the power of open source. Of course, you want something maintained, but all in all, to maximize the potential of open source is also about being active in the community and using more open source as the data says. So some of my key things and key takeaways, I think, in regards to open source usage, I think that open source, as I've talked about, leads to higher development performance, and high performers, they want to continue to use more and more open source. So, but there is some risk around it. So it's important to make informed decisions not only about security and compliance, which has been very popular in the past years, but also about looking at the community and how you can truly leverage the open source through the community side of things. And also, I think I usually have this note in most of my presentation because I think it's so important, regardless of if the presentation is about this or not. But developers love open source, and it's important to make it easy to use it for them, but also to make it easy for them to contribute back to it. It should not be a 27-step process, because that is discouraging. I think making that easy is very important. Thank you so much for coming and listening to my talk. I hope you enjoyed it. If you have any questions, I'm happy to stay around and have a discussion and answer them. We have a couple of questions.
All right, we're already unmuting everyone, and so if you have any questions, you can just unmute your microphone. And yeah.
So looking at the popularity, but through license infringement and that kind of perspective. So they're looking at, if we go back to why developers choose to leave open source projects, there are actually some in this particular survey. Some answer that there were legal requirements that push them towards the choice of stopping this particular project. So I think there's some correlation there, definitely. And if we look at look here as well, we can see that they found a small correlation between having good licensing and clearly defined licenses. So failed projects had to a larger extent did not use good licensing practices. Any other thoughts or questions? No, it doesn't. It doesn't seem so.
Last call for any more questions? No, I think we are done then. Thank you all for coming.
Great. Thank you very much for coming.